Okay, this is simplifying a third question, but sort of in disguise. Don't let this confuse you too much. We'll worry about that later. But essentially, if we're going to simplify this, we need to rationalize the denominator. We need to get rid of that root 2 from the bottom. And we do that by multiplying the top and the bottom by root 2. So we're going to multiply the top by root 2. I'm going to put it first, the root 2, because I just think it's slightly easier to realize that the root 3 plus root 27 has to then be in a bracket. Now the bottom here, if I multiply by root 2, I'll write it out in full, but I'm doing root 2 times root 2. Remember, that is just 2. So the top, if I do root 2 times root 3, well, that's just the same as root 6. And if I do root 2 times root 27, well, I can make that the same as the root of 2 times 27. In other words, the square root of 54. The bottom then is now 2. Now, obviously, I need to express my answer as a single surd, so I need to carry on a little bit. I can see that root 6 can't be simplified. In order to simplify, I'd have to write 6 as a square number multiplied by something, and I can't see a square number that goes into 6. I can, though, if I look at root 54, I can see that root 54, well, 54 is actually 9 times 6, so I'm going to stick the 9 first. Let's carry on with the 2 at the bottom. I can see that 9 is a square number that goes into 54. Okay, what I've now got is root 6 plus, and remember I can split root 9 times root 6 into, if I just do it over here, square root of 9 times the square root of 6. And remember, that's the same, well, the square root of 9 is 3, so in other words, this becomes 3 root 6. So this root 9 times root 6 is actually just the same as 3 root 6. So I'm going to write the top as 3 root 6, and then on the bottom we've still got our 2. Okay, now I need to think about the top. I've got root 6 plus 3 root 6. Now remember, to add surds, it's a bit like adding x's. If we did x plus 3x, then that would just be 4x. And in the same way, root 6 plus 3 root 6 is just 4 root 6. In other words, we've now got 4 root 6 over 2. And I can cancel the 4 and the 2 to give me 2 and 1. In other words, what I've got is 2 root 6. Now, unfortunately, this still doesn't agree with what we've got here. So what I'm going to do is, if you like, undoing the surds, I'm going to realize that 2 is actually the same as the square root of 4. So this 2 root 6 can be written as root 4 times root 6. In other words, this is the same as the square root of 4 times 6. In other words, it's the square root of 24. In other words, if we look at what we've got up here, the square root of k, I've now got the square root of 24, so k is equal to 24. Now, I've just thought of an alternative way of doing that. If we go right back to the beginning here, I've realized that my root 3 plus root 27, I could simplify the root 27 right from the word go. And I could write it as root 3 plus, remember 27 is just the same as 9 times 3, and that's over root 2. Maybe slightly easier way of doing it here. If we've got here, then this is root 3, and this can be written as, well, the square root of 9 is 3 times the square root of 3, so in other words, it's just 3 root 3, and that's still over root 2. Right, if we carry on, we've got root 3 plus 3 root 3, well, that's 4 root 3, and that's still over root 2. If I now rationalize the denominator by multiplying the top and the bottom by root 2, the top now becomes 4, and then root 3 times root 3 is root 6, and the bottom, root 2 times root 2 is 2, and we get the same as before. So in other words, we cancel, and we've got 2 and 1, and we've got 2 root 6, and then we can carry on in the same way as I did over here.